Here's one more problem that was taken from the AP exam regarding the subject of air resistance. This time we have a skier on an incline, and that skier is subject to a resistance force in the form F equals negative BV. And the very first question is simply to draw a free body diagram, right? It says on the dot below that represents the skier, draw a free body diagram indicating labeling all the forces that act on the skier while they descend down the hill. Let's do something. Let's copy this, paste it here. We've got a little more room to work. Okay, well, normal force points that way. Gravity points straight down. And then there's a resistive force pointing back up the hill. I was about to write KV, but this is one of those cases where we choose BV instead. All right. Any other forces? Right? They say it's a frictionless hill, so there's no force of friction. Let's see, well, if they move forward, isn't there some force propelling them forward? Well, wait a minute. Yeah, but that comes from one of the components of gravity, right? So if we wanted to, we could also show the y-axis. Okay, so nothing needs to be done to normal force or BV, but mg should be broken into components. So there's nothing wrong with making a second free body diagram with all the forces resolved. Normal force. Oh, this is a little sloppy. Let me try again. Normal force. Mg sine theta. Mg cosine theta. And BV. As long as mg sine theta is greater in magnitude than BV, then there'll be acceleration in the forward direction. But I'm going to assume at some point this force BV will grow to be as large as mg sine theta, and at that point the skier will have reached terminal velocity. Okay, so we're done with part A. Part B, write a differential equation that can be used to solve for velocity as a function of time. So it doesn't say to solve and figure out what the function is. It just write a differential equation that could be used if we wanted to derive that function. So we recognize that normal force and mg cosine theta cancel each other out. So the net force is equal to mg sine theta minus bv. By Newton's second law, we can replace net force with ma. So ma is equal to mg sine theta minus bv. If we divide through by m, we get a equals g sine theta minus bv over m. So lastly, if we want to make this a differential equation, we just need to substitute in place of a the expression dv dt. So dv dt is equal to g sine theta minus bv over m. There we have it. That represents some differential equation that we could solve to come up with velocity as a function of time if we wanted to. Determine an expression for the terminal velocity. So at some point, the free body diagram will look like this. Normal force points this way. There's a component of gravity, mg cosine theta, pointing this way. Mg sine theta points down the hill, and initially there's no resistive force at all, right? When the skier first starts out and is at rest, then there's no air resistance. Then he moves a little faster, and the resistive force gets this big. Moves a little faster still, and it gets this big. But you know where I'm going with this. Eventually, the resistive force pointing opposite mg sine theta is just as large in magnitude. So At that point, it represents equilibrium. The net force is 0. Doesn't mean the skier stops. It means the skier stops speeding up, and whatever the velocity is at that point will be terminal velocity. So we can actually put the subscript t here. So that means b times terminal velocity is equal to mg sine theta. So terminal velocity is mg sine theta divided by b. Solve the differential equation in part B in order to determine velocity as a function of time. Okay, I thought the problem might ask that. So let's go ahead and solve this differential equation. Okay, so there's our starting point. So the next step would be maybe we can rearrange a little bit here. We can multiply everything through both sides of the equation by negative m over b. Okay, so this will give us negative m over b times dv dt is equal to negative mg over b sine theta plus v. Okay, a little cross multiplying and we get dv divided by v minus mg sine theta over b is equal to negative b over m times dt. We integrate on both sides of the equation. As t goes, at time t equals 0, the velocity of the skier starts out at 0, and at some later time, the speed has grown to some value v. So the left side of the equation evaluates as the natural log of v minus mg sine theta over b minus the natural log of negative mg sine theta over b. The right side is really easy. It just becomes negative b over mt. And let's see, the natural log of a minus the natural log of b is the same thing as the natural log of a over b. So we can express this a little bit better. We have the natural log of v minus mg sine theta over b, all divided by negative mg sine theta over b. That equals negative b over m times t. However, let's look back here. Mg sine theta over b is the same thing as terminal velocity. So let's make this even neater looking. We have just the natural log of v minus v terminal divided by negative v terminal equals negative b over m times t. E raised to both sides of the equation will help us simplify, and we get v minus v terminal divided by negative v terminal is e to the negative b over mt, and if we multiply both sides of the equation by negative v terminal and then we add v terminal to both sides of the equation, if we do two steps in one, we'll get v is equal to vt minus vt e to the negative b over mt. And so if we factor out v terminal, we get our final expression. Velocity is a function of time. It can be expressed as v terminal times the quantity 1 minus e to the negative b over mt. There we go. So the last question is sketch a graph, all right? Sketch a graph of acceleration as a function of time. So we've got the equation for velocity as a function of time. To get acceleration, well, acceleration is dv dt, so we need to take the derivative of this expression. Okay, so what will that give us? Let's see. It'll give us vt, well, it's d dt of vt minus vt e to the negative b over mt well, the derivative of this part goes to 0. And then we get what? Negative vt times negative b over m times e to the negative b over mt. So the negatives cancel out, and we get vt times b over m times e to the negative b over mt. But what is vt? Vt is mg sine theta over b. So mg sine theta over b times b over m, e to the negative b over mt. B cancels, m cancels, so we have acceleration is equal to g sine theta times e to the negative b over mt. So this is telling us that the initial acceleration is equal to g sine theta, and from there it exponentially decays. Okay, and we would expect the initial acceleration is g sine theta because that's the acceleration you get for objects when they're on an incline. So the graph just looks like this. The acceleration exponentially decays and approaches 0 asymptotically, and it has an initial value of g sine theta. Okay, hey, thanks for watching.